If you have not yet watched the inverse sine function video, please watch that first. I'm going to skip some things here that I talk about in that video, so this one's going to be much shorter. Just like with sine, with cosine we have a function that is not one-to-one, and therefore this function does not pass the horizontal line test. So I'm going to have to restrict this, just like we did with sine, so that we get a region of this graph that is one-to-one, so that when we do the inverse we get a function. So with sine, that was from negative pi over 2 to pi over 2. As you see with cosine, that will not be the same range, because if I restrict this from negative pi over 2 to pi over 2, I again do not have a one-to-one function here. So where we're going to restrict cosine is from 0 to pi. Right? If we look between 0 and pi, all of those y values that we have for cosine will be unique. Right? Those are all unique values, and therefore that is our restriction with cosine. So for the original cosine function, just like sine, the domain is all real numbers, and the range is negative 1 to 1. Okay, that's the same as sine. Right? I can plug in anything I want to, and my answer will always be between negative 1 and 1 when I evaluate the cosine of it. Which means my domain for inverse cosine is going to be negative 1 to 1. I have to plug in things in that range of values in order to get an answer. So my domain for inverse cosine is negative 1 to 1. And my range is going to be that restriction that we put on our cosine function. So we're restricting that between 0 and pi. So the answers that we get for inverse cosine are always going to be somewhere between 0 and pi. If you look at your trig chart and you look down the cosine column, every y value here, or every value that you have for cosine between the angles of 0 and pi, right? So if you look in this radian column, between 0 and pi, all of those cosine values are unique. So that is where you're going to look for cosine. When you do inverse cos, you're simply looking from 0 to pi and telling me which one of those angles is the answer, right? So I don't have to look anywhere else. It's the top part of the unit circle. Okay, so keep that in mind. For inverse cos, you are looking between 0 and pi and giving me something in that range. So, what is the inverse cosine of root 2 over 2? So which angle between 0 and pi has a cosine of the square root of 2 over 2? And that is at pi over 4. Which angle between 0 and pi has a cosine of 0? That's at the very top. That's pi over 2. I'm going to skip C for a minute and go to D. Arc cos, again, same as inverse cosine. Those two things mean the same exact thing. Arc cos of negative 1/2. So here's where it differs from sine. So with sine, we would say, all right, which one in quadrant 1 has a half? And then I'll just call that negative that thing. Right? So if this were arc sine, I would say, well, pi over 6 has a sine of 1/2, so this would be negative pi over 6. That's not what we're doing with arc cosine. So with arc cos, we're going from 0 to pi. Which angle in that range has a cosine of negative 1/2? And that's going to be the angle 2 pi over 3. Okay, we couldn't look in quadrant 2 at all for inverse sine, but for inverse cosine we can. 2 pi over 3. Arc cos of 5/7. Okay, 5/7 is not a unit circle value. So I want to check, is 5/7 in this range? And it is, right? So it's in my domain here of negative 1 to 1. So because 5/7 is between negative 1 and 1, I can evaluate this. And I'm simply just going to go to Desmos to do that. And I'm going to do the inverse cosine of 5/7, which gives me 0.775, we'll call it. So 0.775. It's not a unit circle value, but I do get a value there because 5/7 is in my domain. Just to show you the graphs really quickly of cosine and inverse cos, this is our graph of cosine. Here's inverse cosine, which means that we had to, in order to get that one-to-one look, we had to restrict our cosine function to 0 to pi. Okay, so if I restrict cosine just between 0 and pi, then my inverse function and that function are reflective about y equals x, making them both both the inverse and the original function functions. Okay, so for arc cos, you're looking between 0 and pi in quadrant 1, quadrant 2. That's where you're getting your answers.